Hello my friend and welcome to a new video. In this video we're gonna solve exercises that related to motion with constant acceleration. Before we start, let me remind you with the big five equations that related to motion with constant acceleration. So the first equation is v is equal v0 plus at. From this equation we will notice that x and x0 are missed. The second equation is v average is equal v0 plus v over 2. The third equation x is equal x0 plus v plus v0 over 2 times t. And the fourth equation x is equal x0 plus v0t plus half at squared. Notice that the final velocity in this equation is missed. And the final equation that independent of time, v squared equal v squared 0 plus 2a delta x, knowing that delta x is the distance traveled. Okay, also we will need to know that the acceleration, the SI unit of the acceleration is meter per second squared, the SI unit of velocity is meter per second, and the SI unit of x and x0, the final position and the initial position in SI unit is given by in meter, and we know that time, the SI unit of time is in second. The most important thing is to know that the first equation and the fourth and the fifth one are very important. So let's start by solving the first exercise. A firefighter slides down a pole in a fire station with an acceleration of 6.2 meter per second squared. So the acceleration is given here. Let's write 6.2 meter per second squared. If the firefighter starts at rest, whenever we have starting from rest, we need to write that the initial velocity is equal to 0 if we have this term, the rest, and slides for a distance. So the distance traveled, delta x, it's the distance traveled, 3.7 meter. What is his final speed? So we need to know what is the final speed. So the next step, to answer this question, we need to choose one of the five equations from this box. Notice that according to the given here, the time is not mentioned, so it's better to use the fifth one, since in the fifth ones is independent of time, and we can easily calculate the final velocity by applying this equation. So we're gonna apply the fifth equation. V squared is equal v0 squared plus 2a delta x. Now all the ingredients are ready to use. The final velocity squared is equal 0 squared plus 2 times the acceleration, which is 6.2, times delta x. We know that delta x is 3.7. So in order to find the final velocity without a square, we need to take the root of both sides. So under radical 0 squared plus 2, 6.2, 3.7. Plug this in the calculator and you will get the answer that the final velocity is 6.8. But since all the physical quantities in this equation are in the SI unit, the acceleration in meter per second squared, the velocity is in meter per second, and delta x in meter, and okay, there is no time here. Anyway, also the final answer should be in SI unit, and we know the SI unit of the final velocity is given by meter per second. Okay. Okay, a car with the initial velocity of 12 meter per second. So the initial velocity here, v0 is equal 12 meter per second, comes to rest. So the final velocity in this situation is 0. in 3.5 seconds, so the time needed to become in rest is 0. 3.5, sorry, seconds. What is the car's average acceleration? So we need to find the average acceleration in this case during braking. Give both magnitude and sign. Magnitude means the numerical value, and the sign whether it's positive or negative sign. How can we solve like this question in order to find the average acceleration? We can also here pick up one of the equations according to the given. We're gonna pick in this time, since there is no positions here, no distance traveled doesn't mentioned here in this question, we're gonna pick up the first question, the first equation. V is equal V0 plus AT. Knowing that we want A, so we're gonna solve this equation in terms of A, or it's better to pick up another equation. We know that according to the definition of the acceleration, we know the average acceleration is given by the change of velocity of a changing of time. This is the let's say the prime version of the first equation. This is another form, another version of the first equation. It's just by rearranging the first equation we will get this equation. So I'm gonna use this equation, or if you want you can, if you can handle with this equation by rearrange it in order to solve it for A, it's better for you. Anyway, I'm gonna pick up this equation in order to find the average acceleration. So we have time, it's equivalent to delta t, so it's v minus v0 over t. V it's the final velocity, and we know that the final velocity is 0 and the initial velocity is 12 and the time is 3.5 seconds. Plug this in the calculator and finally we will get the answer, and the answer in this case is minus 3.5.4. it's around 0.4. So what is the unit used here? Since the velocity is here in SI unit, meter per second, and also the time here in SI unit, which is in seconds, so the final answer should be in SI unit also, and the SI unit of the acceleration is meter per second squared. Okay, you are driving through a town at 60 meters per second. Just a minute. Given. Ask. And the answer. Okay. So we are driving now for 60 meters per second. So this is the initial velocity. We suppose that this is the initial velocity, 60 meters per second. When suddenly a car backs out of a driveway in front of you, you apply the brakes and begin decelerating. Okay, after we applying the brakes in order to avoid crashing with the car, so the final velocity should be 0. Okay, not mentioned until now, so we're gonna write the acceleration here. The acceleration, since it's decelerating, let's suppose we are going to the positive direction. If we want to decelerate, we need to apply a negative acceleration, because whenever the direction of velocity is in opposite with the direction of acceleration, we have decelerated motion. If the velocity has the same direction of the acceleration, then we have accelerated motion, so we need to add here a negative sign. 3.2 meter per second squared. How much time does it take to stop? It means the final velocity is equal 0. So we need to find the time. What is the time needed to stop? Not just that, here we will need to find the time, and the physical quantities that are given here is the initial velocity, the acceleration, and the velocity, the final velocity. It's clearly that we're gonna pick up the first equation. So give according to the first equation, v is equal v0 plus at. The final velocity is 0, sorry. The initial velocity is 16, and the acceleration is negative 3.2. Time is the time, which is unknown. We're gonna move 16 to another side, so minus 16 is equal minus a 3.2 t. Since minus a 3.2 is multiplied by t, so we need to divide by minus a 3.2 for both sides in order to eliminate the number front of t. And finally we will get that the time need to make the car stops is 5 seconds. How did we know that the unit of time in this answer, it will be in second? It will be in second. It's clearly that because all the physical quantities that in this equation are in SI unit. 16 is in meter per second, which is in SI unit of the velocity. Minus a 3.2 is in meter per second, which is in SI unit. So also the final answer should be in SI unit, and we know that the SI unit of time is second. This is for part A. Now we're gonna solve part B. After braking for half the time found in part A, is your speed 8 meter per second or greater than 8 meter per second or less than 8 meter per second? Support, this is another part. Anyway, so we know that we need 5 seconds in order to stop here. The question is, in the halfway, the velocity in the halfway is not 0, but is the velocity is 8 or greater than 8 or less than 8? We know that the velocity in velocity time graph for a constant acceleration is a linear. It should be linear. If it's increasing, it's going up. If it's decreasing, according to this situation, decelerated motion, it goes down. So since it's a linear for constant acceleration, the velocity will be half the initial velocity when we braked for half the time. Therefore, the speed after braking 2.5 seconds will be equal to 8 meter per second. So we're gonna write now, because the velocity varies linearly with time, for constant acceleration, the velocity will be half the initial velocity time. And therefore, after 2.5 seconds, half the time, the speed should be 8, half the speed, which is 8 meter per second. For part C, they ask us to support your answer with calculation. So we're gonna support now our answer with calculation. We need to calculate the final velocity after half of the time. We know that half of the time t is equal 5 seconds, so half of it is 2.5 seconds, and we need to find what is v after 2.5 seconds, knowing that the initial velocity is 16 meter per second. V is equal, is not is unknown. V0 is 16, but let's first write the equation that we will use. V0 plus AT. Since we don't have distance, we're gonna use also this equation once again. So the final velocity is equal V0, which is 16, plus the acceleration is minus 3.2, and the time is half of the time, 2.5. After plug this in the calculator, we will get the same answer, which is 8 meter per second. So whenever we have constant acceleration, so half the time means half the velocity. Okay, see you in next video, and thank you for watching these exercises. Bye bye.